So let me see. I sometimes don't know. I'm given more than one option to share. Do you see my desktop?
Yes.
Okay. Let me try to.
This looks like your browser.
Okay. Do you see Bloom here?
Yes.
Yeah. Hugging
Okay.
Face.
Well, what I thought I'd do before I talk about the original things, a little bit more SQL, a little bit more about what you do with that messy data set I sent you. I ran into a couple of things of interest that I simply want to share. One of them is the Bloom project, which I was not familiar with. You know, I know about OpenAI and Google and 1,000 other these large language models. Here's one that's 176 billion parameters or weights, available in 59 languages in open access. The others are proprietary. This one is not. So you can basically delete this and put your own sentence in. In fact, I did that and I thought that's what I wanted to share. So this is now available if you want it to complete sentences or request it to write for you. It's a text generator, but it really read this prompting tips because it isn't what you think. And in terms of performance, let me just show you. I basically asked it 10 questions. Should I worry about monkeypox? Okay. Yes, the CDC recommends. Okay, not bad. I asked him about the James Webb Telescope. So this is not really asking to complete a sentence, but I just wanted to see. So that was gobbledygook. What is your favorite recipe for chocolate cake? Gobbledygook. Write a poem in iambic pentameter. Not so good. Are Bitcoins a good investment? Not so good. Donald Trump will likely just, in this case, asking them to finish it. And it went on, not finishing the sentence. And again, wasn't quite what I expected. Solution for the drought in the Southwest US would be to take some water from the Central Valley and then irrigate the Central something. And I don't know why these are cut off. So here's one though, who is Jolie Sarimba and Ziba, who I didn't know, and she's not in Wikipedia, but that gave a fairly detailed explanation. Then I asked, what is the geometric mean of 0.5 and 0.65? And it didn't give an answer. And then summer is a wonderful time to relax, visit the beach, and take a vacation. So you can come up with your own conclusions. To me, at this point, I don't know. I'm not impressed. I'm not sure how I'd use it in healthcare, but just understanding that these things are being built and it's a giant race to see who can make the biggest and the best. But what are the two downsides? These things require incredible computing powers, and their carbon footprint is really bad. Somebody said to train on this model is the same thing as flying a super not tanker, but a large aircraft all the way across the United States. So you know they really are not practical. I don't know where they're headed, but this is the first one that's open source that you can access, and I put the URL for that for you. All right, here's another one. I was unaware that Amazon had a machine learning university. So you can take courses, there's a textbook, there's a lot of stuff. But what caught my attention was something called Machine Learning University Explain. Notice they highlighted AI here, but the beauty of this is that they have taken a core number of lectures or concepts in data science, and we'll just go over those real quickly. I want to demonstrate at least one where train, test, validate, receiver operator curve, precision and recall. These are all pretty much interactive where you can change the image and change whatever you're calculating. So it's very interactive. A very good explanation of random force, I might add. Decision trees, if you actually care, and I don't blame you if you don't, you want to see some of the math and ways that it selects the root node and how it calculates node impurity and so forth. So how does the decision tree actually work? It's very good. By the same token, bias and variance explains. I don't think you need to know about double descent. But let's go back and look at the receiver operator curve, because I think they did something that I thought was very cool. Is remember that the receiver operator curve dates back to the World War II, when the very first crude radar was trying to tell if it's an aircraft or not. So let's shift this threshold to 0.5, which is the default for every receiver operator curve. And what you see here is you see the arrow here to the right to classify the plane versus over here classify cloud. It's like logistic regression. If you're to this side of it, you're going to probably be a 1. If you're over on this side, you're going to be a 0, although you'll get a probability. It won't be all 0.1. It could be 0.8, 0.7, whatever. But the point is, if you shift this, first of all, it'll show you what happens in the curve. So let's take the roughly 0.5 here. So the true positive rate there is 0.53, false positive rate 0.25. So let's shift it over this way, and you'll notice that now you have almost pure airplanes, but you missed a ton of them. So, you know, the false negative rate would be real high. The false positive rate, you only have 2 clouds over here. So the false positive rate's real low. Move it over this way, you get kind of the opposite problem. True positive rate is high. You got all those planes, but your false positive rate is 50%. So for every airplane, you've got a cloud. So it's just a good demonstration of that. I will comment, I don't know how many of you all have looked at the calibration curve in orange and looked at the other options for looking at sensitivity versus specificity and recall versus precision. You can do the same thing in essence. So I just wanted to say to you all, if you feel like you need a refresher on any of these, this is one of the nicest ones that I've seen. Now, kind of related to this, I don't know how many people attended the MIS last week, but I gave a talk on imbalanced data set using moving the rock threshold that I'm going to just bring up, because, you know, we've talked about what you can do. There's some standard things you can do, but what I did is I took a data set available on Kaggle. I'm not sure why it's recording me at the bottom. I don't know if you can even see that, but anyway.
Bob, just in case you're showing something, we're seeing still your browser window with the rock and AUC. Are you showing a different window?
You should see a slide that says the problem. You're not?
Okay. Yeah, so maybe try to reshare your desktop. You can just click on share again and then click on the, usually it's like the top left-hand corner.
All right, well, let me click stop share and then click share screen again.
Share screen, and then usually it's the top left.
Okay, thank you.
And then we can see your whole desktop. Okay.
Okay.
Yeah, we see it now.
So I think, and I'm more than happy to share this PowerPoint for those people who didn't attend, but it so happens that Kaggle has a data set where you're trying to predict who's going to get a stroke. The problem there is, out of 5,000 patients, only 249 did develop a stroke, and so 4,800 didn't. So that's a good data set to look at this. And so what happens is that you get pretty good AUC, classification accuracy that's great, a horrible F1, lousy precision and recall, and the specificity is great. Why? Because it's focusing all on those negatives, the people that didn't have a stroke. Log loss, we've not spent any time on. That is an option in orange. And what that does is it compares the predicted model with the expected model. A perfect model would be a 1, a terrible model would be a 0. So understand, you can use log loss, just right click the word model here and select log loss. It's just one more parameter, if you will. But in any case, what the take home here is that in class imbalance, so many of these are highly misleading. The worst is classification accuracy. Next is the AUC. And if you look here, so it predicted no stroke, but in fact, there were 246. Look at all the false negatives, 246, totally unacceptable, in other words. So again, there are multiple things that you can do. You can report the precision recall curve instead of the AUC or AUROC, and it's going to be poor, but it'll be more accurate. And we've talked about this before. You could undersample that 4,800. You can oversample the minority using something like SMOTE, but understand there really are no guidelines. There's no unanimous opinion on what you're supposed to do. One of the newer ways is you can generate more of the minority class. The stroke people using a GAN, which is interesting. And I've explained that in logistic regression and random forest, you can weight the minority class to give it a favorable outcome. And doing that, just clicking that box that says balance class imbalance, notice the F1 score did improve quite a bit. The other thing, just so you're aware of it, and that's all this is, FYI, F1 score is the gold standard, but you can calculate an F2 and a F.5. Here's how you calculate F2, but ironically, the result, for whatever reason, actually got worse. So that didn't work. But that is, if false negatives are a greater concern, you use the F2. I've mentioned in the past Matthew's correlation coefficient, which is kind of looks at both classes, majority and minority, and gives you an overall score. Once again, 0 to 1. So 0.05 is horrendous. And I would have to say this is probably a lousy model. I don't care what you do with it. But the one that, so this prompted me say, well, no, almost nobody talks about moving the receiver operator curve. I wanted to be sure you all understood that. This is similar to what I showed you in the Machine Learning University Explain software. You shift this left and right, it changes the threshold. They don't give numbers here, but this threshold here would be 0.5 undoubtedly. You can move it to the left to 0.5, and suddenly now you've got most of the sick people, but now you've got lots of false positives. So you decrease, you also have fewer of these negatives. So that's the result of shifting it. So if you look at over here, if your threshold's down here, you minimize false positives. If it's up here, you minimize false negatives. But let's look. So Orange does a wonderful thing. You all may not have done this, but just pull up. This is the heart disease prediction one. Just mouse over it, and it'll tell you what the threshold is. And you can calculate, just go across here for the sensitivity or recall, and go down here. Remember that this is 1 minus it. So if the line is 0.5, 1 minus 0.5 is 0.5. 1 minus 0.6 is 0.4. So that's how you calculate this manually. So you know, this just gives you what it looks like on a well-balanced data set where the minority and the majority are pretty close together. They're pretty equal. So let's look at the next one. In orange, I mentioned if you go to the calibration plot, check sensitivity and specificity. Because what I did is I took the slider, I moved it from 0.5 over here where the recall is starting to drop and the specificity is increasing. And I said, well, this is a compromise. This optimizes specificity and sensitivity. The threshold is way down at 0.05, but here, now the sensitivity is 0.70, much better. The specificity dropped. But that just gives you an idea. This is an educational thing that's not available anywhere that I'm aware of, other than that Machine Learning University one. So here's the curve for this data set that's imbalanced. And so at a threshold of 0.4, the sensitivity is 0.036, specificity 0.99, false positive rate is down. So if all you're interested is in negatives, this is a good place to be. But if you're interested in positives and sensitivity, your threshold needs to be 0.05. Now you can actually calculate this. I haven't seen this in many textbooks. I'm just sharing this. I wouldn't spend a second. Don't crowd your brain with this. but there's something called the geometric mean, not the F1 is the harmonic mean of sensitivity and specificity. So all they do is multiply sensitivity by specificity, take the square root of it. Larger the better. The Uden index, you take the true positive rate minus the false positive rate. The larger the result, the better. So what I did here is I took the thresholds. I did the calculated sensitivity specificity, but I threw in G means and Uden. So the bigger, the better, right? So if you look at here, sure enough, a threshold of 0.05 is around the best. Now, maybe tweak that slightly, but the point is, I just wanted to point out that you can adopt a different threshold. So here's a threshold of 0.5 and a threshold of 0.05. And you can see the accuracy dropped. AUC stays the same. The curve, regardless of the threshold, the curve stays the same. Hence, the AUC stays the same. The F1 is much better, sensitivity much better, precision worse, and because of more false positives, and specificity drops. So I'm just demonstrating this to understand that's one more tool in your toolkit. So this is something, so remember this, that be alert when reading an article when only the AUC or the classification accuracy are published and nothing else, that's a red flag. They're cherry picking. They should include that, other measures, including a confusion matrix. And the other thing is be alert when the AUC and classification accuracy looks good as well as specificity and the other measures are poor, go in and look at how many subjects there were in the minority data set because you're probably dealing with class imbalance. But regardless of what you do, ultimately, this is a clinical decision. In other words, how many false positives, false negatives are you willing to accept? Because it just depends on whether you're talking about predicting cancer, sepsis, whatever. You may be willing to accept some false positives and not be willing to accept false negatives. But ultimately, it's a clinical decision. I just wanted to introduce you to some tools that you may not be familiar with. And I'm more than happy to share this PowerPoint. If you just email me, I'll attach it. Let's see. So one other thing in the US news, you may have seen the fact that 80% of Americans have glyphosate in their urine, which is a byproduct of the weed killer Roundup. There's lawsuits about Roundup, and it looks like it probably is associated with more non-Hodgkin's lymphoma. But I wanted to emphasize, I talk about the value of NHANES. So this is the National Health and Nutrition Examination Survey. That's where that news. Yeah.
I'm not sure about other people, but it's kind of weird. What I see on my screen is sort of the PowerPoint trying to minimize, but
okay. Let me stop the share and start over. Thank you. That's again. There's no way I would have known that.
I'm sure it looks fine on your screen. It could be a Zoom.
That's right. That's right. So
thanks, Flora. I was seeing that same thing.
Okay, great.
All right.
Yep,
so
now we see it. Yep.
Okay. So what I'm saying is when you go, let me go down to the bottom here. So what they're saying in essence is, and they got this sort of backwards. I don't know why they did this. So if you had an abnormal glyphosate level, they label that as 0. Below the detectable levels is 1. That's kind of goes against the grain, but don't worry about it. So 1,885 out of 2,310 had a detectable level in their urine. Now, keep in mind that, of course, you get a little bit of it from food, so we don't know exactly what that means. But the point is, NHANES is valuable. So what I then did is I downloaded some demographics and downloaded the questionnaire of who's had cancer. And to make a long story short, I data mined it to determine whether more people complained of cancer in the detectable than the non-detectable class or category. The answer was no. So again, I'm just encouraging you, you get all this information here. They even nice enough did it in classes, or they gave you a range. So you could do a recession. Your output could be numerical. Here is 0.141 to 8.13, or classification. It's normal or abnormal or detectable or non-detectable. So I'm just trying to highlight the fact that NHANES is a very valuable resource if you're interested in epidemiology and public health. So that was the idea behind that. And let me see if I can pull up one other thing that's, I think, worthwhile, because we're going to look at let's see, we're going to look at SQL in terms.
You
Oh,
might have to
did do it
reshare your
again?
yes.
Yeah, sorry.
Or what you can do is you can just share your desktop. So then I think then we'll see whatever you see on the desktop if you bring up a new
All right,
window.
let's do that.
Mhm. Okay, yeah, now we see
You see an orange?
Yeah.
Okay. So the thing I wanted to point out, so here I have the urine glyphosate levels that I'm just sort of taking a look, doing a little bit of exploratory data analysis. But if you say, how do you merge these three files, demographics, history of disease, and glyphosate levels, the answer is you upload a CSV file to here, you do your second one here, and you set this one as data to extra data to merge it. And you open this up, and all you have to do is append columns from extra data. You're attaching, if you have 10 columns and you want to add 3 more, that's all you're doing, 3 more. And so how do you match it? All NHANES data has a sequence number. So that's your common denominator, every patient. So that's all you do, sequence to sequence. So all I did was take one data set, attach another one, so I've got 2 now combined. I take the 2 combined and I add the third one here. And now, so I have 3 combined, and then I save it as, you save it as 3 combined files.csv. But that's all, I'll tell you, that's a lot faster than SQL. I still think SQL is an interesting, worth knowing, and it's pretty easy to do joins, but not this easy. So that's the only reason I mention this, is it's something you should know about. Let me see if there was anything else I wanted to share before I get to the original thing that we were going to do. Any questions about those, by the way, those kind of interesting things that I commented on this week?
David just wrote on the chat that says that is a great tip.
Yeah, and thank you for showing that joins are probably one of the most powerful things in data science. There are lots of data sets by themselves, whether it's in your own institution or not, but the real power comes when you can join 2 different data sets together. And that looks a lot easier than writing code.
Yeah, it is. And in fact, let me just show you. So this is bit.io. And for those of you who, maybe didn't attend last time or whatever, this is chapter 15 that I'm just kind of introducing you to data bases and data analysis using SQL. But I can say bit.io is by far the best thing I ran into. I tested, I don't remember, 6 or 7, and they all have problems. I mean, either they require, you have to pay for them, or you have to spin up a server. Like MySQL is certainly the standard, but it is not easy to launch. It is, you really have to have a little bit of background in computer science to launch the daggone thing. Whereas here, you just really just hit new database and upload the data and you're good to go. So let me explain what I've done here. And this is available to you. So this adults NHANES is, I think, about 5,000 adults. And I took, I don't remember how many, maybe 10 CSV files and combined them all. And so this, again, has, I think, over 100 predictors, if you will. Now, these are separate CSV files. We're going to combine, we can combine a couple of these, but this one, let's bring this back up. And I put some, I don't remember who did this, but they had the means of inputting fake names. So these patients have fake names that are, of course, not real. But so it has, and I also converted, NHANES has its own code, which, it's a pain to have to look it up. So albumin, for instance, you know what that is. Let me see if I'm having a little trouble seeing the scroll. But anyway, there's something like 140. There's even grip strength. There's light exposure. There's pulmonary function. There's everything. So this is a great data set to mine. But here's some of the individual files. So when you pull those up, what you're going to see is the, see this? This is NHANES language that you have to translate and convert to something that's meaningful. So these are these 4 individual NHANES files. This is the sum of those. So let me do a couple of simple commands here. And by the way, if you all want access to this bit.io thing to play with it, it looks to me that all I have to do is put your email in and you get invited into play is what it looks like. And you just click data. And again, I can't tell you how, to me, user-friendly this is. So here's one where the command is simply select BMI, that's a category, column, and gender from adults. The data set over here is adults underscore nhanes.csv. It has to be in double quotes. And you always end it with a semicolon and then you run query. If you get an error, you'll see a red thing down there and you just have to go back and check your script, your code. So here's your BMI and your gender. That's all that's all it took. Now, could you have done that in Excel? Of course you could. Let me do another one where let's put a where clause in there because you can add lots of different stuff. So where BMI is greater than or equal to 25, let's say, and gender equals 1, females. Run query, see how fast that is. So here's everybody that's overweight at least, that's a female. That's all it took. That's pretty simple. Now you can also select drugs, or in this case, a drug is a script. Let me just show you. And this has to be in single quotes. Why? Because otherwise it'll think it's a column. And so where drugs equal losartan. Actually, oops, no wonder. Senior moment 100. So we could have put, so there's only this many patients on losartan. We could have put, for instance, SCQN, so you can see who they are. So there's the number of the patients. Do you see how that works? Is that fairly intuitive, I think? And again, I remind you that you can look at all of this after the fact, and also the SQL Bolt, B-O-L-T, is a wonderful, simple tutorial to do all of this. So let's do another 1 or 2, and then we'll shift to something else. But select A1C, which is hemoglobin A1C, that pretty good parameter for diabetes. From this data set, where the A1C is greater than or equal to 6.5, which is the newer definition of diabetes, if you will. So there's, and again, we could have done sequence, or does that make sense?
Yeah, I have a question, Bob.
Yeah.
So is a query dependent on the data I put in, or is it smart and would recognize the medication Cosar as losartan, or will it only then filter out if somebody actually entered losartan? So is it smart
yeah,
or is it?
No, it's very stupid. No, that's a good question. Currently, SQL does not have any intelligence whatsoever, and that's why if you make the slightest mistake, if you even capitalizing things may create an error, and you have to remember comma here, you have to remember semicolon at the very end. But to answer your question, no, it has to be losartan, and if it's capitalized, it should be capitalized. So that's one of the problems with it. Now you can do, let me just add here another clause. So what we've done here is order by hemoglobin A1C ascending. So 6.5, 6.6. Does that make sense? And it can be descending. So if you look in the textbook, though, a table 15.1 and 15.2, it'll give you all of that. Okay. I mean, in other words, it'll give you other clauses. I'm just not going to inundate you with this because I don't know how many of you all are interested in learning SQL. It's by far easier than Python to do the basics. You know, again, you can play with this data set if you want to be invited in to play with this particular one. That's fine. Let's do a join. And remember, the wild card is an asterisk. That means select all. So we're going to go show you how to do a join. I'm going to take this. And then we're going to put, let me. But it does have to be exactly what you see on the left. So it's telling full join on, then you have to name that. Demo, and that's demo, again in quotes. And then that has to be equals see, and I didn't do the quotes. So that's the kind of thing that traps you and gives you error message. You still may get an error message. Let's just see. Nope, there we go. So what we've done is, again, we've joined the BMX CSV file with the demo CSV file, and it's based on this column sequence. And here it is. And what you could do then is export it. See the download. So that's the idea of it, that you could combine a ton of these. It takes a while. As I say, I think Orange is way faster and much less of a chance of an error. But that's all I was going to show you on this. You're welcome, as I say, to have at it and do whatever else. Okay.
Bob, can I ask a couple of questions?
Sure.
I'm just wondering, in terms of the SQL syntax, is this sort of standard syntax for any SQL program, or is this a little bit specific to bit.io, and then a different SQL program might use
Okay.
slightly different syntax.
Thank you for asking that question. This is slightly different. It's called PostgRE, GRE. Generally, it's probably 90% the same as any SQL or SQL, but it is a slightly different variety. And so you have to pay attention to that. But by and large, it's not going to affect much of what you do. But yeah, it is specifically, if you look up at the top, it says PostgRE SQL. So that is sort of the variety. And so you might every once in a while put in a command you learn somewhere else and it doesn't work. But they're also up here. Let me see if I can find it under docs. There are some more examples of commands in SQL as well.
Thanks, Bob. Yeah.
So you're welcome. This is really just kind of an elective thing in my opinion, but I thought just based on the fact that SQL is easy to understand by and large, you all should at least have some feel for it. So that's just simply, you're getting exposure to it and that's all.
One more question.
Yeah.
So in terms of, let's say if some of us we're given access to our own EMR in the hospital saying, hey, you want to do some research, you have access, you're from the clinical side, go at it, right? And so is it that the only way to actually get data out of most of the EMRs right now is still using SQL, or do other programs that some hospitals have that can actually be more graphical, that you can pick certain fields and it can output it as a CSV? Because I'm assuming that just getting it into the CSV format that you want is one of the challenges.
Yeah, well, let me just comment. If they have a standard relational database, then the absolute gold standard is SQL to extract it, probably as a CSV file, and put it into a data warehouse or a data lake or a data lakehouse. But to get to any relational database, a SQL is the gold standard. Now, keep in mind, there are plenty of non-relational databases popping up, not just graph databases, but a whole series of other ones that I outline in the chapter. But this is why most data scientists have to know SQL, because there's still the gold standard is relational database, even though Anthony certainly would like to see more people using a graph database, but that requires learning a new querying language. It's not SQL. So there are some obstacles there moving to graph databases. But again, if you're trying to access a hospital database and download data, probably in a CSV format, then the answer is you'll need to know SQL.
To know. Thank you.
Okay. Let me see. Just trying to think. I guess what I want to do is, let me see if I can pull up an Excel. You all were given, I don't know how many of you all looked at this file. Can you see that now, or do I need to reshare?
No, it's good. We see this Excel file.
Okay.
Yeah.
So again, I've got a few things that I did with it. The whole idea of this was to give you some tasks to do as initial cleaning up. That this is more likely what you're going to encounter, missing data. And I hope that you all know basic spreadsheets, by the way. All of you know how to filter, to go to data and then click filter, and then come. And the best way to do that, by the way, is click the entire headers, then go here. That way, for instance, one of the commands was, do you have clean stuff for gender, all your terms clean? The answer is no. You got M, you got male, you got F, you got fem, you got female. So the answer is, this is one of the best ways. Initially, when you're trying to look at data, you're doing that exploratory data analysis, you're going to go to each one of these. And I'm not at all opposed. And here again, you notice you've got small and SM. That has to be cleaned up. Then you do find and replace, basically. And hopefully you all know how to do that. It's usually find, replace. So instead of LG, you change it to large. But I mean, all this kind of stuff, conditional formatting is very important. And I'm not here to sell textbooks, but we have an entire chapter on that introduction to biomedical data science devoted to spreadsheets. Because in my opinion, there's nothing wrong with being really good with Excel or Google Sheets. It's a starting point, but it's a good starting point. You can do other stuff with all the other programs I've introduced, but there's nothing wrong with getting started here. So I don't know. Let me stop with that and ask, did anybody come up with any findings in that data set that they want to share that they thought was very noteworthy? Because again, what I've generally given you is clean data sets that didn't require a whole lot of polishing, that didn't have much missing data, but that's not realistic. I had to change that raw data into a meaningful data set. I had to make a lot of changes, and I also had to create a column, diabetic yes or no, based on a hemoglobin A1C higher than 6.5. So I had to do a lot of manipulating to get the data to the point where you could interpret it. But what I wanted to just share with you in the minutes remaining is, so what you're going to do is you're going to clean it up, probably in Excel, maybe less so in Orange, but in Orange, you can do great exploratory data analysis. You'd almost always start with feature statistics. Here, remember, this has not been divided into diabetes yes or no yet. So I said I divided on gender, so you could certainly go through and take a look at all of these and see, gee, are there differences that are visual? You can look for missing data. You can look for medium and mean. Remember, if there's a big difference between these two, then it's skewed. And in fact, in other words, look at the difference between 89 and 106. Well, sure enough, when you look at this, it's skewed to the right, even without doing a formal distribution. But so feature statistics should be number one. I love box plot. I do want to show you that if you look at, for instance, like take the gender here, there is this statistical difference between hips and men and women. You kind of know that. But I would assume that when you looked at waist, there would have been too. In this population, an African-American adult population, there wasn't. Normally in a Caucasian population, at least, there is generally a difference. Men tend to have a pot belly and lose their rear end, so to speak. They have a different configuration as they get to be middle age, and women, the weight tends to go to the hips. So this group was a little bit different. So that's a take-home message that may be related to race or ethnicity. But anyway, this does a great job of plotting all that. You can look at a bunch of different things too. I didn't really care about the two different counties. You could look at, are the counties different in age? No, but you could go to the counties and go through each one of these and say, I don't even need that category. It's not useful. So anyway, you do this, but understand in almost any data set, you have the ability to do supervised or unsupervised learning. So you can, under supervised, you can find a categorical output like diabetes, yes or no. And so try to do a prediction model on that using the parameters or predictors that you have. By the same token, if you were interested in just the raw hemoglobin A1 score, that's numerical. So you could create a regression model and try to see what predicts the hemoglobin A1C. So either approach would be reasonable, and a hierarchical clustering, which I'll go over in a second. But I thought, let me finish up first with exploratory data analysis. So the box plot, I just noted that the one I noticed, I looked at many of them. Distributions, you always have to look at, and again, another way to look at hip and waist by gender, but you have to definitely decide on what's a bin width, because you can make it big, you can make it large, or small or large, and it changes your curve. So be aware of that. when you start playing with the bin width. Kernel density is what most people look to make these curves, and you can hide the bars and just look at those curves, which look like something nice for a PowerPoint. But that gives you an idea. So this is the hip distribution. And up here, it shows females in blue. So it's kind of interesting. It's saying there are more men, the distribution here, the distribution of women is broader, and there's more outliers to the right. So that's all that you're seeing there. So you should be doing that as well. Correlations, of course, the thing I try to remind you about that is you can look at a few of them, or you can look at all of them. And what came up interesting that I can't totally explain is height and HDL. We'll see that with the unsupervised learning in a minute. But that was an interesting finding. The other thing, and here's a scatter plot. So you can look at things like age and HDL ratio. What does that do over time? The answer is it goes up. Females and males are about the same. So you can always look for correlation with correlation widget and the scatter plot. And then another approach, by the way, that I just want to remind you about is you can go into select rows. Okay, I want to see the hemoglobin A1C greater than 6.5. And then you send out two outputs. One is the matching data, and the other one is unmatched data. So here, matched data, and I think this is covered up, let's see, is the one's hemoglobin A1C of 6.5 or greater, and here is everybody the rest. So you could look at a box plot of both of these and compare. That's not as nice as having both on one graph, but that's another way that you can divide up your patients, is using the select rows. So you could do that. You can add a condition where gender is female. So you could narrow your database or your data down quite a bit this way. All right, but if nobody else has any real take-home points that they found on their own, I'm going to skip exploratory data analysis, not skip it, but move on to unsupervised learning, where you're simply saying, are there groups in there of interest? And you could use k-means, but we pointed out before, the problem with k-means is you almost have to know ahead of time how many clusters there are. So you have to play with it. You can do a silhouette score. There are things you can do, but I think one of the more intuitive ones in a way is hierarchical clustering. And so what I put here, and the instructions are here, and I hope I shared this orange file with you. I think I did. Anyway, the distance things is basically what it accomplishes. You're going to try to see if there's similarity between columns, and you're going to use Euclidean distance. That's all that means. Is so you're looking for similarity between columns, because those are your predictors. You're trying to see if there are groups. So here's hierarchical clustering, and you can move this slider, by the way. This one is up at height ratio, they call it 80%. It's up top here would be 100%, but you can move it. You could argue, well, that I think there's more groups or less groups. But so you can look at this, but let's stop there for a minute. You're using Ward, using the name here as a drop down. But what goes together is somewhat logical. Hip, waist, and weight go together. Cholesterol ratio, age, stable glucose, and glycohemoglobin. But interesting enough, blood pressure, systolic and diastolic, and height go together, as well as HDL. I don't know if people that are taller or heavier more inclined to have diabetes, and hence their HDL is lower. I don't know. But as I said, when we looked at correlations, that's real. Well, let me introduce one other thing here that is a heat map. I wondered, where in the world is the heat map? Well, there is a heat map, and you can, let me change this to attribute names, the predictor names. So this gives you a heat map of things that correlate. And again, I don't know that this is any more helpful than the correlation thing that we've already done, but this gives you a visual rendering of some of the correlations. And here are some, remember I mentioned the groups. So this green group is hip, weight, and waist forms a group. There's another group and another group here. So I'm just introducing you to tools that you can use that's interesting. Any questions on that? And there was somebody, I don't know what's in chat here. Okay, Dan Haynes.
Yeah, I have a question, Bob, if I may. So how do I know that this is a true correlation? Because I'm not aware about the height and HDL level.
Well, and again, of course, correlation doesn't equal causation either. Well, I would also do a literature search. I would investigate it further. I mean, I'd have to look further, but that's the whole idea of data mining, to come up with something like that and go, well, that's odd. Is it real? You know, are there any outliers that are screwing this up? You know, so the burden's on you as the budding data scientist to figure out whether that's significant, and is there a reason for it? Is it real? And do a literature search to see if that's been described before, because I don't think there's any immediate explanation for that that I'm aware of. So I'm not sure what to make out of it, but it's interesting. But you can see how it identified those groups, and there's probably better data sets than the one I just showed you, but that was convenient. But in any data set, you basically could do that. Now, one other thing, somebody mentioned the Kaggle data competition. There is a one that's out there that you could join, but there's already about 80 teams. So that's a little discouraging. It came from the Mayo Clinic, where they have, basically what they did is people had cerebral thrombectomies, which is not that common. So automatically, this is a bit strange. So that, I don't know if that meant they all went in and had carotid studies, and if they had a clot that they could get to, they analyzed it, the past slides. In other words, they looked at it under a microscope. Because believe me, the average person with a stroke doesn't have any pathological specimen. They don't biopsy anything. But the Mayo Clinic, being the Mayo Clinic, they must have extracted some clot. And so what they're trying to see is whether that clot looks like it's cardiac origin or not. So it's a matter of using computer vision to look at the clot to see if there's any subgroups of any kind. So that's the challenge, which is interesting on one level, but I'm a little bit confused. I need more information about how the Mayo Clinic got these, and because that's just not standard of care, in other words. So that, I just let you know about that. Okay. Lastly, where do we go forward from here? To me, this pretty well finishes the textbook and what I wanted to do for your group. But at the same time, I don't want to leave you cold. I mean, I did think about this fall creating the new data science group and starting all over again, to just simply to introduce as many people to data science as possible. Okay. That being said, though, I mean, first of all, you've got the Medical Intelligence Society to get more data science tips and more journal articles and all that. But I'm just trying to have an open conversation about you all's thoughts about moving forward. Because as I say, my first choice was to consider starting a new group. I have some new contacts at Western University. There's always some new people from the board review courses that want to workshop, so forth and so on. But you all have been super faithful. So I want to know, you know, we could do something different before the workshop or after on just advanced data science, or another potpourri where we just share stuff. What are your thoughts?
May I ask a question? Is it possible to review some published papers and see how they analyze data using Orange, for example? Do you have any paper in your mind that was interesting for you that you can share with us, how they use these techniques?
Well, we would have, well, first of all, most of what's written in the medical literature that used Orange is by the authors of Orange, which are computational biologists. In other words, they looked at things like mice nuclei and different kinds of cells, and to compare things. So the answer is, I think we would have to find data sets, articles that had data sets available to analyze. I mean, certainly we could analyze more data down the road, but you all also can do that on your own. I've tried to give you access to as many data sets as I know are out there, with the idea, let you all do the exploratory data analysis, let you all do the supervised learning, the unsupervised learning. There are also tons of images out there where you all can use Google, or excuse me, well, it's Google Inception 3 is the convolutional neural network, but you can analyze images on your own, really. So it's just, again, I'm trying to point you all in the right direction and let you do a lot on your own, but I don't want to leave you cold either. I'm always available by email for any of these projects. We'll probably have another data competition that I'll include you. In other words, sometime in the next 6 months to 8 months, we'll probably have a data competition, preferably using Orange, but I think we may allow any other tool and just have people submit their project. And last year, there was a cash prize. But again, where do you all think you want to be a year from now?
Well, I'll speak for myself. First of all, I want to thank you very much for this grand tour that you've taken us on. My data science needs are sometimes I do a lot of it and sometimes I do a little of it. But what I've learned here more than anything else is tools and things that I can use when I need them. And because of the links to the book and the links to the lectures, I have the ability to get it whenever I need it. But I think everybody's use case is very different to mine. So sometimes I might go through 4 months where I'm doing a heck of a lot of data science, and then I might go 8 months where I barely touch it. And so my needs have been met. Thank you very much.
Okay. Well, again, this was intended to be introductory. I mean, you can get into incredible detail with data science to the point where your head's spinning. And I try to avoid that. I try to give you the core principles or core concepts, basically. How about others, input from others? What are your needs moving forward?
Hi, everyone. Sorry, I'm in South Africa and it's winter, so it's already dark. But I want to thank you, Bob, for your commitment to teach us the Orange tools. Indeed, I've been learning quite a lot. And on my side, I would want to continue because it reminds me of keeping on using the tool of Orange, because I do biostatistics for my institution. So it gives me also many ideas of what I can apply that many people don't know about. Another university has already started wanting to collaborate with me because they see a bit of skill that I have in machine learning. So I wouldn't mind continuing joining you in whatever sessions that you're doing. Thanks.
Okay. And again, I'm not sure that we're going to see an intermediate course come out of me in the next year. I mean, in other words, it would be logical to have this introductory one and then to have a more intermediate. But I don't think that I'm going to do that. But I'm always available if you have questions or emails. No, I appreciate, again, how faithful and loyal you all have been month to month, but, signing on and asking good questions. I do appreciate that. But, you know, keep reading and keep analyzing data. There's no shortcut. I do remind you that Orange was designed for education, unlike some of the other programs that really weren't designed for education. And that's why it's used at a lot of different universities worldwide, not so much in the United States, but other countries have used it because it's more intuitive. It's easier to understand. Other comments?
Yeah, I'll add. Thanks, Bob. So I find that I think Orange is a good way for me to do like preliminary stuff on my data. So I can do something and then take it to my statisticians or data scientists. So maybe I know if I have something or not, and they can check it. But I think a good idea would be if we could all meet and like people could troubleshoot something they're working on. Like I feel like that would be really helpful for me if I'm like, I'm not sure if I'm doing this right. Can you guys give me advice or tell me what to do better?
Yeah, I thought about that. I mean, this could be ad hoc in the sense that if we had some project or something that somebody brought to our attention, an interesting data project, we could tackle it as a group. We could convene, in other words, have a Zoom session. And then when we're finished, we can then run it by a data scientist. Alfonso probably would be willing if he had the time, but I'm willing to do that. You know, and I'm certainly available at almost every day of the week to handle some of those questions, but I'm just not sure. Again, I want to start or I want to continue this formally unless somebody comes up with a really bright idea, because I'm already committing basically to 2 workshops along with MIS, the board review, literature review. You know, I'm a reviewer for intelligence-based medicine. So there's a lot of things I do behind the scenes. So I'm trying not to overcommit in essence. Other comments? And you're also welcome to join the Australian one as well. I'm doing things tiny bit different for that group. I'm sending them the data ahead of time. I'm sending them the Orange file ahead of time. That looks like it's going to be it'll be Friday evening, which would be Saturday morning for them. So let me know if for some reason you want to join that. We have at least one person that may do that. But otherwise, again, I thank you very much for your attendance and your attention, and that stay in touch, and that I will try to include you on anytime I have anything interesting. I'll try to include you on that email.
Yeah, I just want to second the gratefulness and appreciation for your time and expertise in sharing this with us on the weekend. And for me personally, I learned a lot. So it's like learning a foreign language to me. And I joined a little bit later in the course. So I wouldn't mind if you don't mind having me in the other. So I get the front part of it as well. So please let me know when you will have the beginning of it.
Okay, the beginning as opposed to the Australian one. Is that what you're saying?
Oh, or the Australian one, whatever is less, time.
Okay, the Australian one will be August the 19th at 5 p.m. Central, and that's chapter 5, by the way. And then the new one, I don't know yet. It's when we can get together 10 or 15 people and it makes sense. So, and it helps me if I can do, say, a Friday evening, then turn around and do a Saturday mornings. That way I'm not taking up too many weekends per month. So stay tuned. I'll include you on the Australian one, and I'll put you down for the new one as well. Okay.
Thank you so much.
Okay. Well, just please stay in touch, you all. I'm just an email away, and happy to include you with any, future stuff. But y'all enjoy your weekend. Stay safe.
Thank you very much.
Thank you.
Thank you
Bye.
so much. Thank you. Bye-bye, everybody.
Bye, everyone.
Bye.
Thank you.